Hello, welcome to Science Chomp. Today we're going to be looking at Boyle's law. Now, to put it simply, Boyle's law states that if you squash a gas, the pressure goes up. And if you make a gas expand, the pressure goes down. And it can be summarized as P1 times V1 is equal to P2 times V2. Now, the condition for this is that the temperature must remain constant. In this equation, P is pressure and V is volume, and the 1's refer to before and the 2's refer to afterwards. The units for pressure are ATM, PSI, PA, which is pascals, and KPa, which is kilopascals. So you need to be aware of this because they don't always tell you a gas with a pressure of 5 atm. It will say a gas at 5 atm, for example. Either way, it doesn't really matter because all you're doing is you're multiplying them out. The volume, we've got units of meters cubed, centimeters cubed, liters, and milliliters. So what we're going to do today and right now is look at how to work out pressure and volume in certain questions. Okay, so I've got a worksheet over here. And I'm going to have a look at question number 2. And it says to compress nitrogen at 1 atm from 750 milliliters to 500 milliliters, what must the new pressure be if the temperature is kept constant? So let's have a look at that. We're going to start off with an equation. And my equation is P1 times V1 is equal to P2 times V2. And it's asking me to find out the new pressure, and the new pressure is P2. So let's work out the numbers. So it says 1 atm for P1, so I'm going to write 1 here, times V1, which is 750, is equal to P2, which is something we don't know. We don't know what P2 is, times V2, which is 500 milliliters. Okay, I've written milliliters here, but not over here, but it doesn't matter. Okay, so the next thing is what we got to do is we've got to get that times 500 and put it over there. And when you take things over the other side of the equal sign, they become the opposite. So instead of times 500, it becomes divide 500. So you end up like this: 1 times 750 divided by 500, which is equal to P2, like so. So let's work this out. 1 times 750 is 750, divided by 500, and that's going to give us 1.5. And we have to use the same unit as we had for P1. And if you have a look at the question, it was ATM. ATM is atmosphere, so 1.5 ATM. Simple enough, straightforward enough. Let's have a look at another question. Let's look at question number 7. It says a student collects 25 milliliters of gas at 80 kilopascals. What volume would this gas occupy at 100 kilopascals? There is no change in temperature or mass. So again, as before, we start off with our equation. P1 times V1 is equal to P2 times V2. Let's have a look at what it's asking us to work out. What volume would this gas occupy at this pressure? So we're asking you to work out V2. All right, so let's first of all put in the numbers. So P1 is 25 milliliters times V1, which is 80 kilopascals, is equal to P2, which is 100, times V2, and we don't know what V2 is. So again, as before, we've got to get rid of this times 100. We just got to take it over to the other side, and the times becomes a divide. So we end up with 25 times 80 divided by 100, which is equal to V2, like so. And then you just simply work it out. So 25 times 80, which equals 2,000, divided by 100, which equals 20. Now I can't just write 20, I need to have my unit, and I use the same unit up there, and the unit was milliliters. Okay? Simple as that, very straightforward. So just to summarize, I'm going to show you this table down here. Right, we've got here P1, V1, P2, V2. To work out P1, so it would be that one down there, it's P2 times V2 divided by V1. To work out V1, for example, that one there, it's P2 times V2 divided by P1. To work out P2, P1 times V1 divided by V2. And to work out V2, which in this case you don't have to, but let's suppose you did, you would do V2 is equal to P1 times V1 divided by P2. It's as simple as that. Thank you very much for watching. Goodbye.